See, among the timers that is available in a microcontroller, one will be used as microcontroller. Mostly it will have the count value up to 255. That is what my understanding. Right. If you disable that watchdog timer, you can use the timer as general purpose timer also. See, they dedicated one timer for watchdog. If you want to use it as a watchdog, you can use it. If you disable that watchdog capability, you can use that as a general purpose timer also. So now you understood, right, what is meant by watchdog timer and why it is used. It is to, or it stops system from the hanging, right? So that's why they have that one. That is required when your project is little big or complete perfect embedded system will have the watchdog timer implemented. Right. So the watchdog timer, to implement the watchdog timer, you need to write the code. It is not like just configuring a bit will make the system to run for you. No, you have to write them. You have to load that watchdog timer value then and there, right, to use it in your program. Clear?
Clear.
Yes, sir.
Some of the timers can also act as a counter. As they are generating delay, when you supply PWM signals, which is having high and low, they can count as well. The timer can be used as a counter. Timer can be used as a counter. Each time it receives a signal, it increases the counter value. Right, this is helpful to find out the speed to do the speed calculations for counting the stuffs. For those, you can use them. Like that is also possible. The timer can be configured as counter as well. Timer can generate a stream of pulses or single pulse at different frequencies. That's what it can generate a stream of PWM pulses with the same frequency as well as the different frequency. That is possible. It can be used to start and stop task at desired time. Like that we can do. Actually, in PIC 16F877A that we are going to use to develop a system which is having 3 timers. Timer not, timer 1, timer 2, like that. Okay, no? 3 timers we have. We can use those timer for our application. Yeah. So next step is buses. There are 3 different bus: address bus, data bus, control bus. As per their name, address bus will carry the address, data bus will carry the data, control bus will carry the control signal in a microcontroller. If you have that understanding, that is enough about bus. When you take a microcontroller, what are the things that you have to consider? What are the things that you have to inspect? You have to validate the microcontroller, whether that microcontroller will be helpful for our project or not. That is based on different factors: number of peripherals that it has, whether that peripherals are we going to use them in our application. We have to think about them. How many interests that particular product, that microcontroller will support, how many serial ports are there, what is the memory size in terms of KBs. Usually it used to be in KBs. And what is the RAM size, ROM size? ROM means EEPROMs size, right? Data memory size. What is the operating frequency of microcontroller? How many pins it has? We need these things, right? These are called as configurations or attributes of a microcontroller, right? The microcontroller that we are going to use in this course is having a 40 to 44 pins. Actually, we are going to use a PIC controller, which is having either 40 to 44 pins. Operating frequency of that particular controller is 20 megahertz. Maximum you can operate it in this frequency. The data memory of the controller is 368 words, right? I think it's 368 byte, I believe. 368 byte, and ROM, EEPROM is 256 byte. Flash memory is 8K. That means that is what the program memory in this controller, right? In the flash What is the flash?
Are you engineering graduate who want to kickstart your profession in automotive domain? Are automotive professional who want to switch your job to interesting positions with higher packages? Are you professional who look to work for great automotive OEM? Are you software professional who look for automotive job in Germany, France, UK, and US? Not sure about where to start? Then contact Yahasia Software for more details. They have nearly 20 years experience in corporate training and helped many professionals to achieve their dream job in automotive domain. They have students across 67 countries. They are conducting regular training on various topics. Automotive system testing using Python and embedded C for automotive are trending courses from them. Hence, to make your dream true, contact them now using 875-451-8745.
And difference between flash and ROM or EEPROM, that we will study in short. I think it has an advantage. The flash has an advantage that we will see that. Okay, now then operating voltage is 5 volt. It has a registers like status register, option register, indirect function register, function select register, program counter, working register. Like that, we have different registers. Right. Then the timer wise, we have watchdog timer and then general purpose timers. Totally, we have 5 ports A, B, C, D, E. Right. So 5 ports in this controller. And interrupts wise, we can generate nearly 15 different interrupts. That means you can distract this microcontroller in 15 different ways. Right. That we will study that in detail. And then the serial ports, we have USART, multi-channel synchronous serial ports we have in this controller, MS, right? Requirement of embedded development environment, the system used to develop an embedded system must be familiar with your target hardware construction and operation. You should study the data sheet of a microcontroller before you implement any embedded system, because that is going to act like a brain. That is what going to generate the control signal. You have to know complete detail about that microcontroller. For that, you can study the data sheet. Every microcontroller will have a data sheet provided by the chip manufacturer. You can get it. That is available freely in the internet. You can get it and can study. Concentrate primarily on your application and not on the hardware which run them. Right. That means your application, that hardware may have different things. It can have number of time, that is 10 timers also, but you may use only one timer for your application. You have to focus only on that. Better you understand your runtime environment, better you understand your runtime environment, the better you can take advantage of its limited capability and resources. Right? Where you are going to run your application, whether that is suitable, whether our microcontrollers are suitable for that environment. You have to validate that before you start developing any embedded system. Then different aspects considered for embedded system than a personal computer. In a personal computer or a laptop, for that we are investing much. See, if you want to buy a laptop today, you have to spend 20,000. From 20, minimum 20,000 I am talking about. It can go up to 1.5 lakhs. We have laptop and personal computer today. Right. In that, but embedded system also a computer only right now. In that, how reliable your embedded system is. You should not inconsistent, like it is doing sometimes perfect, it is not working sometime perfect, it is sometime it's display exact text that you want to display, sometime the characters are corrupted, sometime it is not sending the signal that is expected. So if that happens, that is very great problem. The reliability of the embedded system should be perfect. Efficiency, it should be efficient, it should not consume time, cost. So in those areas, we have to, it should be an efficient one. The cost wise, it should be cheaper than your personal computer. These are the three factors to consider: reliability, efficiency, and cost.